So to get an approximate value for this, what we're going to do is we're going to get a function that represents this. So I'm going to say, let's let f of x be equal to 2 over the square root of x plus x squared. Okay. Then what we're going to do is we're going to use f at 1, because 1 is very close to 0.99. And so let me just again draw out just kind of a general picture. I really don't care what this looks like. I'm just going to draw out some graph. Okay, so let's assume that we've got our curve. And let's say here is the number 1. Here is 0.99. And so what I'm going to do is I'm going to use this line to estimate this guy. So our estimate, I think we can stop really working through this picture, but again, it's not a bad idea. If you kind of get stuck, go ahead, draw the picture out. We know that dy, okay, our estimated change in y is equal to f prime at the value, at an easy value to compute, okay, times delta x. Okay, and here, so f prime of 1 and delta x, change in our x is 0.01, so it's relatively small. Okay, now f of x was equal to this mess, so f prime is going to be equal to, now what I'm going to do here is I'm going to use my quotient rule. So it's the low times the derivative of the top, so the bottom denominator, times the derivative of the numerator, which is 0, minus the derivative of the bottom times the top, so 2 times the derivative of this guy right here. So that's going to be 1 over 2 square roots of x plus 2x over the denominator squared. Like that. So f prime at 1, now we can go ahead and we can multiply this guy in. So let me actually just write this out. So if I multiply the negative 2 into the numerator, I get negative 1 over square root of x minus 4x all over square root of x plus x squared squared. So f prime at 1, the slope of the tangent line, slope of the green line, is going to be equal to negative 1, okay, minus 4 over 1 plus 1 squared. So this will give me negative 5 over 1 plus 1 is 2, 2 squared is 4. So the slope of the line is negative 5/4, and I'll multiply it by 0.01. So there's my dy. Okay, so now what do we do? Well, we take this and we add to it the function value. Okay, we add to it the function value at 1. So to get our approximate for y, we take dy and we add to it f at 1. So that's dy, which is it's basically negative 5/4 times 0.01 is 1 over 100. Okay, plus f at 1. Well, what is f at 1? Well, f at 1 is going to be equal to 2 over square root of 1 plus 1 squared. So that's 2 over 2, which is 1. Just like that. And so if we go ahead and we put this together, we end up getting, hang on one second. Actually, hang on, I gotta change something here. Our delta x, since we're going left, is negative. So this guy is going to be positive. Okay, because it's a negative times a negative. So this will give me 1 plus, now 5 and 100, that's going to give me 1 over 20, And so this will give me 1 plus 1 over 80. And 1 over 80 is 0.0125. So this gives me 1.0125. I just want to check that just to make sure that I've got that right. Yep. So there we go. Now let me just be clear on what I forgot to write down here. Okay. This guy right here, delta x, the change in the x value from here to here is negative 0.01 because we're moving to the left. Had I moved to the right to 1.01, then it would have been a positive 0.01. So because I'm moving to the left, this guy is negative.